Hello everyone, welcome to another HBL day. So this is our second HBL of the year. Today we're going to continue on our cumulative. So this will be the last few parts of the notes for this chapter. So we are currently at page 10. Okay, so let's continue from here. This is the first time we are going to sort of read the values of a cumulative curve and then answer some simple primary school questions. Okay, so let's start. You can see that there are 40 students, and this T hours is the number of hours they spend surfing the internet on any day. Okay, so that's why you see that if you look at the highest point here, we are looking at 40 students. So there are 40 students, and of course here is all the T hours. Okay, so the maximum guy is going to be 10 hours. Okay, that's all. So you also notice that I wrote down one box equal to 1 because I tend to like to write this down so that when I'm counting the numbers, I'm reading the numbers is easier. So from 0 to 5, there's 5 little squares. So of course 1 square equal to 1. So same thing, there are 5 little squares here, 1 to 10, 9 to 10, so it's 1 unit, right? So each one is 0.2. You will see how this makes it very easy to read later. Okay, let's start with the question first. So the first one, they ask you number of students who surf the internet more than 6.5. So clearly I need to find 6.5 here. So here is in the middle of 6 and 7, right? So 6.5. I go up to the graph. I go up to the number here. The number is 29. Okay, so you pause yourself and ask, is 29 the answer? Because they ask for more than 6.5 hours. Now there are 0 to 29 people who surf the internet 6 to 6.5. So actually 29 is the number of people who surf the internet 6.5 or less, but I want or more. So literally the answer is just 29 to 40. These are the amount of number of people who actually surf 6.5 or more, which is why in the answer here it is actually 40 minus 29. So 11 is the answer, not 29. It's a bit tricky here. After that, you see that percentage of students who surf the internet more than 6 hours. It's the same number, right? So it's still 11 students, but it's more than 6.5 hours. And asking for percentage. So obviously it's going to be the number of students that I'm interested in divided by total times 100. So this is like what? Primary school question. Okay, so that's the answer. You notice the answer key is wrong. So the first one is 11, not 20, I don't know what. Okay, after that, they ask you for the value of T such that 80% of the student surf T hours or less. So I'm looking for a certain number here. And when I go up, I reach here is 80% of all the students. So the first question is, total got 40 people, right? 80% is how many? So again, this is primary school maths. 80% of 40 is equal to 32. So we're looking at the number 32 students if I rank them from lowest to highest. So number 32 in this case will be here. So this number is 32, right? And then I go all the way to the graph. I go down, is 7. Okay, so that means 32 people surf 7 hours or less, and that's exactly what they are asking. So the number 30th, 32 students surf 7 hours, and that's why 7 hours is the answer. Okay, so let's continue. The next part we're going to do something very similar. So again, this is the number of apples, right? So if you look at the total, the highest one is 120. So there are 120 apples in total. Okay, so let's answer the question. So number of apples with mass less than 98. So I need to look for 98 here. So same thing, in this case, one small box is 2. So I'm looking at 100 minus one box, so that's 98, right? So I go up, is 50. Okay, and so again I'm thinking, is 50 the answer? And in this case it is the answer because I want less than 98. So it's 50 or less. That's why the answer is 50. Okay, so 50 apples is correct. After that, percentage of the total number of apples having mass 117 or more. So I want the percentage, right? Or more. So same thing, I need to look for 117. So that will be 120 minus 1 square and a half. So this is our 117 here. Same thing, I go up, I go here, this is 102. Okay, so there are 102 apples which are 117 gram or less, but you notice I want more here, it's not less, which means instead of taking the 102, I need to take the 120 minus 102, divide by the total, so it's 15%. So again, it's primary school maths, right? Then again, I'm asking the same thing here. Value of k such that 20% of the apples have k or more. Okay, so 20% have k or more. So again, I ask myself, what is 20%? So 20% in this case is number 24. So it's the top 24. So it's a bit tricky here because it's the 20% is 20% or more, the highest 20%. So I'm looking at the top 24 apples, which means if I rank from the lowest to the highest, I'm looking at the 96 apple. So how do I get 96? It's because I take 120 minus 24. So I'm looking for the 96th apple. So same thing, I come here, 96 happens to be here. I do go here, I go down, the apple is 114. And that's why the answer is 114. Okay, so again, it's more English than maths, you realize. Okay, then after that, we're going to introduce a new term here. It's called percentile. So percentile simply means that if I divide the number of apples into 100 parts, I'm looking at the number 70th part. Okay, so in this case, I have 120 apples, right? So if I divide by 100, I times 70. That's what I do here. So total 120, divide into 100 parts. I want 70 parts. So that I'm going to get the 84th apple. So the number 84 apple is what I want. So if I go here, go 84 is here. I come here, I come down. For this case, it's 109. So 109 is the answer in this case. Okay, so that's what percentile means. I literally just divide the number of apples into 100 parts. I take 70 parts, and that's all. Okay, so the next part will be something new, because we're going to learn how to find the median, the quotas of a cumulative graph. Again, this is not rocket science, it's actually pretty simple. So the essence of this is we're going to divide the number of, what is this, apples, right? In this case, apples, into 4 parts, 4 equal parts. So this corresponds to 25%. And this is, of course, 50%, 75%, and 100%. So this is pretty similar to the percentile just now. Just that I have fixed numbers, 25, 50, 75, and 100. Quarters, that's why it's called quartiles, right? There's a reason why it's called quartiles, because it's divided into 4 parts. Okay, and that's it. That's all. So in this case, I have 120 apples again. If I divide into 4, we're looking at 30, 60, 90, 120, 4 equal parts. Okay, so that's why I wrote here 30, 60, 90, 120. So I use Q1 to Q4 to sort of represent them. This is not really the exact maths term, but you can think of it that way. So I'm asking myself, the 60th item, the apple, in this case will be the Q2, because it's halfway, right? So I'm just reading off the numbers. So for 30th, I come to here, the number 30 apple. I go to the graph, I go down. This number is 1 box is 2, right? So it's 90 plus 1 box, so it's 92 here. So same thing, 60. I go all the way, I come down. It is I can't really see very well from here, so it's 101, and so on and so forth. So I'm just going through. So the video will show you exactly how I get all these things, but that's the essence of it. So once you get the 4 important numbers, the median is just Q2, which is here. The interquartile range is just, again, Q3 minus Q1 as always. So that's all. That's what we call our interquartile range. So the next part of this, we're going to look at some more common questions. This is like what I call a full question. Let me zoom this a bit. Okay, so this is as big as I can go. So this will be motor vehicles and the speed. So again, there are 100. So if you look at the highest one, it's just 100. Okay, so I'm asking medium, lower quota, upper quota. So again, it's the 25%, 50%, and so on. So you can see that median is the 50th. I know it's 50 because total is 100. So the halfway mark is exactly 50. So it's quite easy because the 100 is a nice number. So 100, 25, 75. So I read off, so 50. I come here, I go down. The number is here, is for, oh sorry, it's here. So it's 49. That's why I write 49 here, and so on and so forth. I'm going to just read off the numbers. So 25% is here, go down, 75 here, go down, and so on. So I get all the 4 numbers, and then I just literally just find the next part. So interquartile range will be Q3 minus Q1. So it's this one minus this one, which is the answer. After that, I want range. So range is again the lowest speed minus the highest speed, right? So the lowest speed is actually here. See, the first person here is 10, not 0, it's 10. And the highest person is over here, which is 80. That's why the answer is just 80 minus 10. Okay, that's all. After that, I want the 10th percentile. That means it's quite low. So out of 100, the 10th percentile will be the 10th guy. And if you go down with this number here, which is 32. So that's why the 10th percentile is 32. After that, I'm again asking the same question. 85% of the motor vehicles have less than this speed. Okay, so quite a lot. So it's 85%. So in this case, 85% will be the 85 car, because 100 is the total, right? So I'm looking at 85 car. 85 is somewhere here, 85. And then I go down, and then the answer will be 62. So 85 is somewhere here. If I do it correctly, somewhere, yeah, somewhere here. So this is the 62, because 85% of the cars will be less than that number. So that's how you read this question. Okay, so the next one is a bit more complicated. This is our classic double cumulative curve. So there's no difference, just that there's more things to read, so it's very confusing, and you might, somewhere you cross eye, you see the wrong number, then you got it wrong. Okay, so you can see that there are 300 students. So I see the highest number is 300. It's some quiz for some school, right? So the maximum is 100 marks. That's why the maximum is 100 marks. But in this case, nobody got 100. Okay, then if you look at what they want is, for school A and school B, I need the same thing. I need medium and interquartile range, which means I need our Q1, Q2, Q3. So to make it simple, I just focus on reading the numbers first, because if I keep reading and calculating, I'm sure going to do it wrong. So I just go for school A. So I want the median. So again, because there are 300, the halfway mark will be 150. The quarter mark will be 75. The 75% mark will be 225, and so on. So I write down the 4 important numbers here to reference, and then I start answering the question. So I want median. So for A and B, I'm looking for Q2. So that will be the number 150 guy. So from 0 to 100, so this is 150. I go. This is the school A. I come down. The number is 62. Then I continue 150. I go all the way to school B. I come down. It is 70. So in one shot, I read 2 graphs. It's faster. So similarly, I go for 75. 75 will be here. The A value. I go some more to the B curve. This is the B value. So these 2, and so on and so forth. So this is the Q3 at 225. So once I get all this number, I start answering, because I want median. So it's 62, and then after that I want interquartile range. So there will be this minus this. After that, for the next part, I want school B. I still want the median, this one. After that, I want the school B's interquartile range, this minus this. That's all. Okay, so these are quite simple, just reading off values. So these are the 2 I want to focus on this time round, because they are asking you to explain things. So in all questions, you will always end up having to explain some stuff. In this case, they will say that, okay, which school perform better. So when it comes to performance, who is faster, who is better, who do more things, whatever, we always compare the median. Median is what we use to measure better or worse. Okay, so if you look at the median, between these 2, 70 is the highest. That's why I say B perform better, because the median is higher. So this is very standard. You always answer it like that. Okay, if you look at the next part, which school the marks were more consistent. Now when it comes to consistent, the spread and along this line, you always use inter-quota range. So if you look at the two answers, we are looking at A's inter-quota range is 18, the B's one is 23. So in this case, there's one more consistent, right? So it should be a smaller number. The smaller the better. That means the bulk of the people from 25% to 75% is more compact. So they are more consistent. All of them are about the same score. So again, in this case, the smaller number is what I want. So I say A is more consistent. I follow the same word because inter-quota range is smaller. So this is very, very standard. Okay, all the questions are answered like that. Okay, so let's continue. The last question. The purpose of this question is not that it is a full question. It will never be a full question like this. But I want to show an example of how cumulative is linked to probability. And again, it's a simple link. It's not rocket science. So again, I have what is this? This is some sweets, right? Students were asked to estimate the mass of the sweet. Okay, so some of them guess 100 plus, some of them guess 300, some of them guess 400, some of them guess 500. Let me zoom this out. Okay, so they guessed. So at the end of the day, they say that okay, the actual mass is 300. So the real answer is 300. So of course, some people got it, some people didn't. Okay, so they ask a probability that a student chosen at random overestimated the mass. So since the answer is 300, anybody who guessed more than 300 has overestimated. So our question is, how many people has guessed more than 300? So 300 is here. If I go here, let me zoom this back again. Okay, so 300 is here. If I go up, and I go here, you notice I use red color to so it's more obvious. So it's 84. So 84 people guessed 300 or less, which means my answer is actually 84 to 200 because this many people all guessed more than 300 here. So that's why the answer is 200 minus 84. And again, I want probability, right? So it's the number of people divided by the total. It's just normal probability, right? So that's the answer is 0.58. And then after that, they ask you number of students who gave estimates within 10% of the actual mass. So the actual mass is 300. Within 10%, that means it's plus 10% minus 10%. So simple math will tell you that 10% is 30, right? So it's 270 to 330. So the number of people who guessed between 270 and 330, which is why on the graph, I look at 270, which is 64 people. I look for 330, which is 100 people. So which means between 100 and 64 are the number of people who guessed between 270 and 330. So again, the answer is already here. That's why the answer is that's 100 minus 64, which is over here 100 minus 64. So you get the people in between. Okay, that's all. So that's all for this chapter. I hope you have learned this chapter and realized that it's actually quite easy. So right now, as you have finished all the notes, again, the key skills are here. These are the things you must know. And then these are the homework questions for this chapter. So take the time to do it during HBL so that we can start revising for our common test 1. Okay, hope you learned something. Thank you and bye-bye.